Where x plus 1. Where do you see x plus 1? Do I have a volunteer? Who sits there usually? Isn't there somebody that usually sits in between you? Are they here? I thought they were here. I thought you were the only one absent. Okay. Anyone? Anyone? X plus 1. Come on. Someone be brave and bold. No? X plus 1. You want to draw it on here? Sure. What color would you like? There's a few colors for you. All right, now, she and I have not talked before, even though I'm a great Latini.
Okay.
I don't know what she's about to write. So let's see. Is that the only one?
No.
And you drew another. Okay. A 1, a 2, a 3. Crunch. 3. You guys know what commercial that is? No? Yes. How many licks does it take to get to the Tootsie Roll Pop? Tootsie Roll center of a Tootsie Roll Pop. The world will never know. So, x plus 1. She has done a very nice job of showing us what those 3 are going to look like, because she took the x amount here and she added it to the 1 here to get that total. Any questions about that? Nice job. All right. How about, can I have a volunteer show me where 3x plus 1 would be? Who wants the mighty pen? 3x plus 1. All right. If you could use either green or a different color, anything other than red. Okay. Again, I, the mighty Zadini, have not spoken with her. Let's see what she comes up with. All right. Can you put perfect? Very nice. Would you agree that that is 3x plus 1? Yes. All right. Very nice. And now, you know what? I kind of messed up there. I messed up because I had Kiani. Why do I want to put the R in there? I had Kiani do technically the third one, didn't I? She tried to stop and just do the first one, but she has shown us 3 different patterns of x plus 1. So I'm going to do what she did initially and show you that this amount right here would have been just x plus 1. Okay? This amount right here would have been x plus 1. And so what do our answers tell us about whether 3x plus 1, which Midori did down here in green, and whether 3 times x plus 1 are equivalent? Are those 2 shaded areas equivalent? Please say no. Please say no. No, they are not. Okay? So basically, we have just shown physically and with a picture that those 2 amounts are not equivalent. Okay? So you can see the picture, and you don't have to write this, but just in case, the picture of 3x plus 1 is not equal to 3 times x plus 1 picture. So they are not equivalent. Okay. Any questions about that? All right, let's go to the next one. Did everybody get that? I think, is this on page 19 right next to it? Okay, so you're probably wondering, why are we doing this? There might be something, if it's not in homework number 2, and I can't remember for sure, it will be in homework number 3. And just a reminder, and also to you, and remind me your name, I can't. Right. That homework number 2, I would like for you to do by tonight, if possible. If possible. Homework number 2, due Thursday at midnight. I have started to grade some of the homework 1s. I've got about half of them done. I don't think I uploaded them to Skyward. So they are graded in Canvas. I haven't uploaded to Skyward yet. But this problem will show up either in 2 or homework 3. All right, so first of all, can you draw a rectangle that has all the corners on the dots? It's not supposed to be overly difficult. Don't overthink it. Can you draw a rectangle that has all the corners on the dots? So go ahead and draw that on that paper while I figure out attendance. Okay, so let's see here. Shania's here, Hayden's here, Munir, Taylor, Andre, Tori, excuse me, Alex, that's who it is. Maya, Josie, Kiani, Renaya, Midori, Josiah, Justin, Jaden, Anthony. Okay. There we go. All right. Draw a rectangle that has all the corners on the dots. So I'm just going to go around. I'm going to pass this to somebody and ask you to draw a rectangle. Can you draw your rectangle above that line? Oh, I'm going to take a security drink, right? Okay.
Wait, I drew mine below. See.
That's okay. Draw that up above.
It's going to be very bad, though.
Just do your best. Okay. All right. Did he meet the criteria? Did you all draw that same exact rectangle? Oh, yeah. Jaden, can you pass it to Jaden right next to you? Can you draw in that upper part, pick a different color if you can. At the upper right-hand corner, there's different colors. Can you draw your rectangle? It's just smaller. Okay, very similar. Did anybody draw exactly like that? All right, let's go one more. Taylor, can you show us what you drew? See if you can pick a different color, red or green. Okay. All right. Anybody draw something different from those 3? Similar? Anybody go vertically that way? Yeah, I probably would have too. All right, let's go down to the second one. If you haven't already, draw a rectangle that has at least one corner that is not a dot? Draw a rectangle that it has at least one corner that is not a dot. Is it possible? Would anyone like to share? Josiah, do you have an answer? Justin? Yeah? Can I give it to you? Can you draw below a rectangle where at least one of the corners is not on a dot? What do you guys think? Is that a rectangle? Does it have at least one of the corners that is not on a dot? Yeah. Anybody else? Anybody want to take a poke at it? Yeah, you have to sometimes think outside the box. Just because there are a bunch of dots there does not mean that we can't not stop at those. We can go beyond those, okay? We could draw something like this, where all of them, except for one. Whoops, that was bad. Oh, that's bad. Now you know how easy or hard it is. Okay? Here I only have one corner that is on the dot. I'm supposed to go down here past. That's supposed to be a straight line segment and then up and over. All right? So sometimes you have to think outside of the box, literally. All right. Now, we're jumping all around today. We are going to go back to page 13 because we did not get this page 13 done. And someone remind us and our newest student that's here today, what is this chapter all about? Please don't say confusion. What is this chapter all about? Come on, you can express yourself here. Thank you. Yes, you said that, Taylor. Yeah. Did you see what I did there? Yeah, that's where you just nod or okay. All right, here we go. For each of the expressions below, without substituting. So we said yesterday you can substitute values in, but without substituting in specific values, because I, the great Thadini, will know if you are doing that mentally. Determine which of the expressions is larger and explain how you know in a sentence or two. So the first one, 5 plus t squared and 3 minus t squared. Which of those is larger and why? Circle the one that you think is larger. Let's make it easy. Circle the larger expression. Circle the larger expression. Has everybody got an answer? Circle the larger expression. Who haven't I talked to yet? Hayden, which did you put down for the larger expression? 5 plus t squared. How many had 5 plus t squared? You are correct. Why is that the larger expression? How could you justify that? Yeah, you are getting added. T squared is being added. So 5 plus t squared is more than t squared. If you say 3 minus t squared, maybe, yes, in most cases, although positive. Yes, most of the time, except, can you think of one value? This is not part of it. Can you think of one or two values where it wouldn't be negative? If t were equal to what? If t is equal to 1, you get 3 minus 1 squared. 3 minus 1 is 2. And, I mean, there are several rational numbers. If t is equal to 0, 3 minus 0 squared is 3. But otherwise, most of the time, this is going to be a negative number, negative value. Okay? Negative value. All right, take a look at the second one. 15 divided by x squared plus 6. And we're comparing that to 15 divided by x squared plus 7. Which is larger? Which is larger? I always have to think about this for a minute. The numerators are obviously the same. Which is larger? Anybody want to take a chance? Take a chance? Take a chance? Renaya, what do you think? Plus 6? Is that what you said? 7? This one? Okay. How many said 15 divided by x squared plus 7? That means the rest of you said the other one. I need somebody to justify why. Can you justify why? Why is that larger than the other? Say it again. 7 is bigger, but that means that's out of the denominator. So if you have 15 pieces, and I know this is only one more, if you have 15 out of 100, okay, that's a lot smaller than if you had, say, 15 out of 20. Now, I know there's a big difference between 20 and 100, but we all see that this is the larger denominator, right? So that means it is not this. You would rather have the same size piece out of a smaller denominator, okay? Same size piece over a smaller denominator is going to be the larger amount. Questions on that? So this, Renaya, as you're coming in, is a class where I'm not spoon feeding you. I cannot tell you everything. You just have to kind of think about it. And sometimes we can draw pictures and things like that to help us too. Okay, but I appreciate your jumping up to try there. All right, the next two, we have quantity s squared plus 2 times quantity s squared plus 1. We're comparing that with quantity s squared plus 4 times quantity s squared plus 3. This might be, I'm okay. Who's got an idea? Maya, what do you think? Uh-huh. How many said that one is the larger one? Yeah. I mean, these s squareds are all the same, right? And if you add 2 and then add 1 to those s squares, yeah, that's a larger number, but adding 4 and 3 is even larger. So that's going to get you the larger answer to a multiplication problem, which is called what again? The answer to a multiplication problem starts with a P. Product. Yes. This is going to be the larger product. And the last one, 8 divided by k squared plus 2 and k squared plus 2. Which one is larger? Which one is larger? Monier, what do you think? Not Monier. Midori. Midori. I'm getting Monier, Midori. Sorry. Okay, which one? Second one, k squared plus 2. How many said k squared plus 2? Yes, because the first one is more, could be a fraction, or if k squared plus 2 is less than 8, then it's going to be a small whole number. Small whole number. Whereas on the other side, k squared plus 2 is definitely going to be a whole number, probably. Okay? Questions on that? How are we doing time-wise? Oh, we got lots of time. All right. Let's jump around again. Let's go now to page 20. Page 20. So just to let you know, you took what I call the pre-FAL quiz, which was that expression sheet, and I said it was not going to be for a grade. Okay? So I'm going to continue looking at those tonight. Tomorrow when you come in, you are going to be matched with someone who seemed to have the same kind of thinking that you did. You made the same mistakes, or you did the same kind of things correctly. Okay? And there will be an activity that we do both tomorrow and Monday. All right? Then we'll have one more lesson on Tuesday. Wednesday and Thursday we will review, and your test is next Friday, a week from this Friday. Yes. Is it page 21? Okay, sorry. I need to take a book home so I get the correct pages here. So distribution on page 21. Okay. What shapes do you see up here in this picture? Rectangles. Do you remember, if you are finding the area of a rectangle, what that formula is for the area of a rectangle? Length, length times width. Yes, she was going to go on and talk about some volume. Length times width. Okay? Length is usually the longer side. Width is usually the shorter side. So if I'm looking at number 1, this first rectangle, what would I do for finding the area of that rectangle? Right. So area 4 times 5, and that is equal to 20. And if I were to label it, that would be units squared. Because when you're finding area, you're really trying to find how many square units there are. But we're not going to label that for the entire time, but I'm just going to show you here. And that is supposed to be a dot for multiplication. All right, number 2. What is the area of this rectangle? 7m. Now, some might be saying m times 7, but remember, in math, we usually like to put the coefficient, which is your number, in front. So 7m would be the better answer choice there. Okay? Now, we're skipping around here. We're just doing a few of these. Take a look at number 5 and that image. taking a look at the first rectangle, what would the area of that first rectangle be for number 5? 4x. This is length times width. So that is 4x. And this is slightly harder, maybe obvious, maybe not. What is the area of this vertical, narrower rectangle? 12. How did you get 12? I see the 3. How did you get 12 then? Yeah, this has the same height. So this 4 can be put over here, and that is 4 times 3. That is 12. If I put those together, what would the total area be for those two rectangles? Say it again. Yes. So the total area of the two rectangles would be 4x plus 12. Basically, what we have done there is we have just shown distributive property. Okay? Here's the 4. It's getting distributed and multiplied with the x, plus it's getting distributed with the 3. Okay? Let's take a look at number 11. As you're all probably going ahead of me. Number 11. What is in the area of that first box? First rectangle. 5x. What about the second rectangle? 35. And if I wanted to talk about the whole thing, I would say 5x plus 35. All right, number 12. What is the area of that first rectangle? Square, rectangle. Actually, is it a square or a rectangle? Square, because they both have the same lengths. What is the area of that? X squared. And of course, a square is a rectangle, so actually it's both, Miss Dee. Haha. And what is the area of the second? 12x. Putting them together, it would be x squared plus 12x. That would be the entire area. Okay. I forgot to look down. So the area as a product means we are multiplying, is 5 times the x plus 7, which is up here. Area as a sum means we are adding, is 5x plus 35. So number 12 here, as I work down, and why don't I just tell you, the area as a product would be what? As a product. Product means I want to multiply. So what times what is that area? Somebody said x. Then what? Yeah, x times x plus 12. X here, that is your shorter side. X plus 12, you are combining those together. That is your longer length. And the area as a sum, I already gave you, would be x squared plus 12x. Questions on those with the pictures? All right, let's go to 14 over here on the side. So now we are distributing. This should be nice, easy review. I feel like students always do a really good job with distributive property. 4 times quantity 4x plus 7 would give me what? Simplified. Class. Yes, 4x plus 28. So that would be the area as a sum. That would be an area as a sum. What about 16? Negative 2 times quantity x plus 4. Negative 2x minus, very good, 8. All right, and 15 at the bottom, 7 times quantity x minus 3. It's going to be, anyone? Yeah, huh? And the last one, x times x plus 9. That's right, x squared plus 9x. Any questions about that? All right. Now, let's go to factoring. Is that on the next page? Is that page 22? Now, factoring is kind of just reverse distributive property. But for some reason, it is so much more difficult for students in general. All right? So, let's take a look at number 2. We have 5x and 20. And we have a short length or a short side with a length of 5. What is the length of this rectangle here in blue? X. Right. So, let's see. Okay. We'll do that in a minute. And if I want to look at the second part, here I have an area of 20. If this side over here on the left is 5, what is the length of that green side for the second rectangle? 4. I don't want that in that. I want that in green. So, did they give you a specific order to write these in? Or they give you an example? They want, it looks like they like the product first. So let's do the product first. Did you have a question? Yeah. Oh, so the product. The product means I'm looking at the whole large rectangle and I want length times width. So what would I write using the product? I'll get you started. It would be 5, that's the shorter side, times the quantity. What is the length of this side up here on top? X plus 4. That is finding the product. It's length times width, or in this case, width times length, because the other side is longer. The second one, we need the sum. The sum of these, which is going to be what? 5x plus 20. Like so. Okay. Number 3. Number 3. Take a look at number 3. They don't give us either one of these values. They just give us 6x, but they are showing that this is 48 and it has a length here of 8. So what does this have to be in this box? 6. Because 6 times 8 gives me 48. And if this is 6, what is this top part going to be? X. Yes. So let's find the product where we multiply first. So take this side. So that's going to be 6 times parentheses. What is the length of the top side here? Right here? X plus 8. Remember, they're just being added together. They're right next to them, so we can combine those. And as I add these together, add them meaning the areas together, that would be what? 6x plus 48. So when you are multiplying, basically you are kind of factoring. When you are adding them together, you're using that distributive property. Number 5, they give us the numbers. 5x plus 35 is equal to 5 times some amount. So here we are actually doing some factoring. They're saying that 5 is the greatest common factor. So if you factor out that 5 or divide by 5, what do you have left that goes in those parentheses right here? So if I had 5x, that is equal to 5 times the quantity when you have that 5 out in front, you are factoring it out, and factoring really means you're kind of dividing. So 5x divided by 5 means you're left with x, and 35 divided by 5 means you have 7. Are you guys just getting quiet all of a sudden, or is this a little bit harder? No? Okay. So where does the 5 go? If I label these as 1, 2, 3, 4, and 5, which of those boxes does the 5 go to? 1, yes. So that is the short side. Where should the x go? Up here in 4. What about 7? Up here at 5. So what would be my area in block 2? 5x, because that's the area of a width of 5 and a length of x. And what is my area at block 3? 35. Questions on that? Okay. Oh, got a little bit of time. 7x minus 21. What is my greatest common factor that I can pull out in front of both of those? 7. And when I factor out that 7, what do I have left? X minus 3, right? You have to factor out that 7 from both terms. All right, so 7 is going to go where? In which of these boxes? Box 1, that is the short side. X minus 3 is going to go on the top. And this is kind of weird here. You're like, minus 3, how do you show a minus 3? Well, yeah, it doesn't work out perfectly. But then when I'm looking at the area, that gets me back to 7x here for that. And 7 times negative 3 would be negative 21. Questions on that? How much time do I have? Oh, we can get one more. 4x minus 16. What can I factor out of both of these? A 4. You always want to find the greatest common factor. That 4 is what goes out in front. So when you divide, what do I have left? 4's cancel out. You have x minus 4. And it's just the last one probably. What can I factor out of these two? 9. So the 9 goes out front. The 9's cancel out here, and I have x minus 9. And look at that, we got her done. So stay in your seats for just a minute. Take a look up here, because we didn't do one of these examples, and I think this is really important. What is my greatest common factor here? Yes, when you have a negative at the very beginning, okay, you want to factor out negativity. Think of it that way. You want to get rid of the negativity. So, yes, you would divide by -3 with both of those, and you would be left with quantity x plus 7. But always remember, if your first term has a negative value, you want to factor out that negative also. Okay? All right. Don't forget, try to get homework number 2 done by midnight tonight. Okay? Hopefully most of you, about half of you, I think, have done homework number 1. I will put up here your partners for tomorrow, and you will sit next to them. Have a great rest of your day. Okay? Say that again. Is it? Yeah. Do I have the tag showing in the back? Oh my gosh! Thank you. Thank you so much. Ah, they said my shirt is inside out. Oh my gosh! Thank you. No, I was running late this morning. That's funny.